The method of connecting a water heater using a flexible metallic conduit terminating in a 30 amps plug-in receptacle may not comply with National Electrical Code requirements. NEC 422.16 states that water heaters shall be permanently connected or cord connected with a flexible cord approved for hard service. Additionally, NEC 400.8 states flexible cord shall not be used as a substitute for the fixed wiring of a structure. The flexible metallic conduit is not considered a flexible cord as per NEC 422.16. The connection method using a plug-in receptacle does not constitute a permanent or cord-connected installation. Loose connections at the plug-in receptacle can lead to arcing, sparking, and overheating. The flexible metallic conduit is susceptible to damage from physical abuse, which can expose the live wires. The remote pilot light can create a potential ignition hazard if it is not properly installed and maintained. To ensure safety and code compliance, it is recommended to connect water heaters using one of the following methods. Firstly, permanent connection. Install the water heater directly to the electrical panel using rigid conduit or cable. Secondly, cord connected. Use a flexible cord approved for hard service and connect the water heater to a dedicated receptacle or outlet box. Other considerations to note are that the water heater should be grounded using an approved grounding method. The electrical panel should have a dedicated circuit for the water heater to prevent overloading. The pilot light should be located in accordance with the manufacturer's instructions and secured to prevent movement. It is important to consult with a qualified electrician for proper installation and to ensure compliance with all applicable codes and regulations. To delve deeper, let's explore the specific sections of the National Electrical Code, or NEC, that govern the installation and wiring of water heaters. We'll begin with Article 422, which covers appliances. Section 422.16, specifically subsection A, directly addresses the connection requirements for water heaters. This section mandates that water heaters be either permanently connected, meaning hardwired directly into the electrical system, or cord connected, using a flexible cord approved for hard service. The key takeaway here is that the connection method must be one of these two options, and it must adhere to the specifications outlined in the code. Now, let's consider the use of flexible metallic conduit, or FMC, terminating in a 30 amps plug-in receptacle. While FMC provides a degree of flexibility and protection for the conductors, it is not classified as a flexible cord under the NEC definition. Flexible cords, as defined in Article 400, are specifically designed and constructed for use in pendant or portable applications, and they must meet stringent requirements for insulation, ampacity, and overall durability. FMC, on the other hand, is primarily intended for use as a raceway to enclose and protect electrical conductors. Therefore, using FMC with a plug-in receptacle does not satisfy the requirements of NEC 422.16. In addition to not meeting the definition of a flexible cord, using a plug-in receptacle connection for a water heater raises concerns about the integrity and reliability of the electrical connection. Plugs and receptacles are designed to be easily disconnected and reconnected, which can lead to wear and tear over time. Loose connections can result in increased resistance, which in turn generates heat. This heat can cause the insulation on the conductors to deteriorate, potentially leading to short circuits, ground faults, and even fires. Furthermore, the frequent insertion and removal of the plug can damage the receptacle, further compromising the electrical connection. Another relevant section of the NEC is Article 400, which governs the use of flexible cords and cables. Section 400.81 specifically prohibits the use of flexible cords as a substitute for the fixed wiring of a structure. This means that flexible cords cannot be used to provide permanent power to appliances or equipment that are intended to be hardwired. The rationale behind this prohibition is that flexible cords are not designed to withstand the rigors of continuous use in a fixed wiring application. They are more susceptible to damage from physical abuse, environmental factors, and normal wear and tear. By using a flexible cord as a substitute for fixed wiring, you are creating a potential safety hazard. Now let's discuss the potential hazards associated with using a non-compliant connection method for a water heater. Firstly, loose connections at the plug-in receptacle can create a significant risk of arcing, sparking, and overheating. As mentioned earlier, increased resistance due to loose connections generates heat, which can damage the insulation and lead to electrical faults. Arcing and sparking can also ignite nearby flammable materials, such as dust, lint, or paper, resulting in a fire. Secondly, the flexible metallic conduit itself is susceptible to damage from physical abuse. If the conduit is crushed, bent, or otherwise damaged, it can expose the live wires inside. This creates a shock hazard for anyone who comes into contact with the damaged conduit. Additionally, exposed wires can also come into contact with grounded metal objects, resulting in a ground fault. Thirdly, the remote pilot light, which is often located separately from the water heater, can create a potential ignition hazard if it is not properly installed and maintained. Pilot lights typically use a small flame to ignite the main burner of the water heater. If the pilot light is not properly shielded or if there is a gas leak, the flame can ignite nearby flammable materials. Therefore, it is crucial to ensure that the pilot light is installed and maintained according to the manufacturer's instructions and all applicable codes. To mitigate these hazards and ensure code compliance, it is essential to follow the recommended practices for connecting water heaters. The preferred method is to establish a permanent connection, which involves hardwiring the water heater directly to the electrical panel using rigid conduit or cable. Rigid conduit provides excellent physical protection for the conductors and ensures a secure, reliable electrical connection. When installing a permanent connection, it is crucial to use the correct size conductors and overcurrent protection device such as a circuit breaker to prevent overloading the circuit. The conductor size should be based on the ampacity rating of the water heater, as specified on the appliance's nameplate. The overcurrent protection device should be sized to protect the conductors from overload and short circuits. Alternatively, a cord-connected installation can be used, provided that a flexible cord approved for hard service is used. Flexible cord approved for hard service are specifically designed to withstand the rigors of continuous use and are less susceptible to damage than standard flexible cords. When using a cord-connected installation, it is essential to connect the water heater to a dedicated receptacle or outlet box. This receptacle or outlet box should be properly grounded and should be located within easy reach of the water heater. The flexible cord should be long enough to allow the water heater to be moved for servicing or maintenance, but it should not be excessively long, as this can create a tripping hazard. In addition to the connection method, there are several other considerations to keep in mind when installing a water heater. Firstly, the water heater must be properly grounded. Grounding provides a low resistance path for fault current to flow back to the electrical panel, which helps to protect against electric shock. The grounding conductor should be connected to the water heater's grounding terminal and to the grounding electrode system of the building. Secondly, the electrical panel should have a dedicated circuit for the water heater. This helps to prevent overloading the circuit and ensures that the water heater has sufficient power to operate properly. The dedicated circuit should be sized based on the ampacity rating of the water heater. Thirdly, the pilot light should be located in accordance with the manufacturer's instructions and secured to prevent movement. This helps to prevent accidental ignition of flammable materials. Finally, it is important to consult with a qualified electrician for proper installation and to ensure compliance with all applicable codes and regulations. A qualified electrician has the knowledge and experience to safely and correctly install a water heater, and they can also help to identify and correct any potential hazards. The National Electrical Code, (ONEC), is a comprehensive set of standards that governs the safe installation of electrical wiring and equipment. It is developed and maintained by the National Fire Protection Association, or NFPA, and is updated every 3 years. The NEC is widely adopted by state and local jurisdictions throughout the United States, and it serves as the basis for many electrical codes around the world. Compliance with the NEC is essential to ensure the safety of people and property. Failure to comply with the NEC can result in fines, penalties, and even legal liability. In addition to the NEC, there may be other applicable codes and regulations that govern the installation of water heaters. These codes and regulations may vary depending on the location and the type of water heater being installed. It is important to check with the local authorities to determine the specific requirements that apply to your situation. When selecting a water heater, it is important to choose a model that is listed by a recognized testing laboratory such as Underwriters Laboratories or all. Listing by a recognized testing laboratory indicates that the water heater has been tested and found to comply with applicable safety standards. It is also important to choose a water heater that is the correct size for your needs. An undersized water heater will not be able to provide enough hot water, while an oversized water heater will waste energy. The size of the water heater should be based on the number of people in your household and your hot water usage habits. When installing a water heater, it is important to follow the manufacturer's instructions carefully. The manufacturer's instructions provide detailed information on how to properly install and operate the water heater. Failure to follow the manufacturer's instructions can void the warranty and may create a safety hazard. After the water heater has been installed, it is important to perform regular maintenance to ensure that it is operating properly. Regular maintenance includes checking the temperature and pressure relief valve, draining the sediment from the tank, and inspecting the electrical connections. By following these guidelines, you can ensure that your water heater is installed safely and correctly and that it provides you with years of reliable service. Remember, electricity can be dangerous, and it is always best to consult with a qualified electrician if you have any questions or concerns. They can ensure your water heater installation meets all safety and code requirements. Furthermore, consider the long-term benefits of upgrading to more energy-efficient water heating technologies. Modern tankless water heaters and heat pump water heaters offer significant energy savings and can reduce your environmental footprint. These advanced systems often come with smart features that allow you to monitor and control your hot water usage, optimizing performance and minimizing energy waste. When evaluating your water heating options, factor in the initial cost, operating expenses, and potential rebates or incentives offered by your local utility company or government agencies. Investing in a high-efficiency water heater can not only save you money on your energy bills but also contribute to a more sustainable future. Consider the benefits of a correctly installed and well-maintained water heating system. It extends beyond just having hot water available when you need it. It's about ensuring the safety of your home and family, complying with electrical codes, and optimizing energy efficiency. Taking the time to understand the electrical requirements, potential hazards, and recommended practices is a worthwhile investment that pays dividends in terms of peace of mind and long-term cost savings.